Hey, what's going on, guys? In this video we are going to see how to solve a first order linear differential equation. Now in order to solve this one, first thing we have to do is we have to check whether the given differential equation in standard form. Standard form of the linear first order linear differential equation is this, that is dy over dx plus p of x y is equal to q of x. P of x is a function that contains x and q of x is another function that contains x. Now let's check the given differential equation is in standard form. Now in order to be in standard form, the first term should be dy over dx only. And if you look at the given one, we have dy over dx and also we have another x. So we have to get rid of this x. Now to get rid of this x, what we can do is we can divide everything by x. And if you divide everything by x, this is going to become dy over dx minus 4 over x y is equal to x power 5 e power x. Right, now we have this one. Now let's check again. Dy over dx, that is first. After that we have to have a function contains x multiplied by y. We have a function that contains x and that's multiplied by y, and after the equal sign we have to have a function that contains x. Also we have a function that contains x. Now this is in standard form. Now we have to find out our px value. Px value is whatever the value we are adding with dy over dx and multiplying by y. So if you look at this one, this value, this negative 4 over x is adding with dy over dx and multiplied by y. So this is going to be our p of x. Now after we find out our p of x, what we have to do is we have to find out our integrating factor. To find out integrating factor, we use this formula, that is e power integral p of x dx. Now if you plug this value, we know that p of x is equal to negative 4 over x, and if we plug this in the integrating factor equation, this is going to be e power integral. I can move the negative 4 to the front, and we are going to have 1 over x remaining dx. And if you integrate 1 over x, that's going to become ln x, ln absolute value x. And also we are going to have constant. We don't have to worry about constant, we don't need that one. And this one, so if you want to cancel this e and ln, you have to move this to the other side. So if you move this to the other side, this is going to become a power, right? So this is going to be e power ln x power minus 4. Right, now we can cancel this e and ln. This is going to be equal to x power minus 4 absolute value, but we don't have to worry about absolute value because we don't need that one. So this is going to be 1 over x power 4, right? And after we found out the integrating factor, we have to multiply both sides of the differential equation by this integrating factor, that is 1 over x power 4, right? So after we multiply this one, we will get dy over dx multiplied by 1 over x power 4, and also in this side we are going to have 4 over, we already have an x, and if this x power 4 combined with this one, this is going to become x power 5 times y. After that, in the other side we are going to have x power 5 remaining, x power 4, that's going to cancel this 4 of this x powers, and we are going to have 1x and e power x. Now after we have this one, here's the interesting thing. Here what we are going to get is this y. If you take this y and this one and differentiate, like if you find the derivative, that's going to be equal to this whole thing. You can check this, it's going to be a product rule. I mean, here it's going to be quotient rule, I guess, but if you do the derivative you will get this back. That's the interesting thing about this first order linear differential equation. After you got this term, you can just get rid of the second one. We have to only bring this first term, and if you find the derivative, that's going to be equal to the whole thing. So we only have to write this one, d over dx y over x power 4, and if we integrate this one, in terms of dx, that should be equal to integration of x power e power x dx. Now when we integrate this one, this integration and this cancels, so we are going to have y over x power 4 is equal to integration of this one. Now this one we have to use this one u dv, integration by parts, right? U dv is equal to uv minus v du. So in order to do this one, we have to find u and dv. Here we have x ex, x power e power x, and dv is the value that's easy to find the integration, and u is the value that's easy to find the derivative. So here we can pick u as x, and du is going to be just 1 dx, right? And dv is going to be e power x, therefore v is going to be e power x dx, therefore v is going to be just e power x. Now if you plug in this equation, you know what, let's separate this one to avoid confusion. Let's separate. Okay, now what we have to do is we have to plug it in this equation, right? Now uv is going to be x times e power x minus integration of v is e power x du is equal to 1 dx, so dx, and if you integrate e power x, that's going to be e power x. So the final answer is going to be x power e power x minus e power x plus constant, right? So this is going to be our integration. Now we can go ahead and plug this one right here. So this is going to be x times e power x minus e power x plus constant. Now after that, now we have almost done this part. Now to write the final answer, we have to write this one in terms of y. So we had to move this x power 4 to the other side. So when we move this x power 4 to the other side, we are going to have y is equal to x power 5 e power x minus x power 4 e power x plus c x power 4. And this is going to be the general solution for this differential equation, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.